Education is the key to a bright future. Empowermefirst.college.
Hello. Today we are talking about another method of finding the LCM and GCF. In the previous video, we talked about how to find the LCM and GCF using the classical way, which means we list the multiples or factors of numbers and just we check the commons. We take the largest common factor for the GCF and the lowest common multiple for the LCM. Prime factorization is a method that will help you find the LCM and GCF in much easier way, and it works for both at the same time. This means that when you want to find LCM and GCF in a question, you can use prime factorization once to find both. We will see how, but first let's start to find how we write numbers as prime factors. The word prime factorization means we are splitting the number into prime factors. I will take, for example, the number 80. Just to remind you that prime is the number that has two factors only, which are 1 and itself. Example about that: 2, 3, 5, 7, 11, 13, 17, 19, and so on. These are the most famous prime numbers. If we think about 80, we will think about it as a product of two numbers. What times what makes 80? There are too many, but let's stick to the multiplication table. 8 times 10. You can think about 20 times 4. You can think about 40 times 2, 5 times 16, whatever. All of them at the end will lead to the same prime factorization, will lead to the same shape. Now, 8, can I split it more? Yes, I can write it as 4 times 2. And 10, I can write it as 2 times 5. Can I split more? 4, I can write it 2 times 2. The rest, I can't. Now, this is something we will take later in the exponent part, but if we have a number multiplied by itself many times, we can write it as an exponent like this: 2 power 4 times 5. That's 80, and this is called the prime factorization of the number 80. As you see, the factors both are prime. There is nothing other than the 2 in the base and the 5 in the base. That's why I call it a prime factorization. Now, let us take another example. If I take the number 30, for example, I will start using something called the tree. So I will split it using a tree. 30 is 3 times 10. Whenever I reach a prime number, I circle it. This means that there is no more factorization for this number, other than 1 times 3, which we don't use. Then 10 is 2 times 5. This is 2 and this is 5. I reached a place where all the numbers at the bottom are circled. This means 30 is equal to 2 times 3 times 5. This is called the prime factorization of 30, and this is the prime factorization in general. Let's go now to the examples to find the LCM and the GCF using prime factorization. If I take this number, this presentation here, and I want to explain how to find LCM and GCF using this method, which is called the prime factorization method. Here you can see what I wrote. You will take all the primes appeared without repeating, and you have to take the highest power for the commons. What do I mean by that? Suppose that I did the prime factorization of a number A. It was 2 power 3 times 3 power 2 times 5 times 7 power 3. A number B, which is 2 power 5 times 3 times 5 power 4 times 11, for example. These numbers are huge for sure. You will not see something like this in the examples, but I am supposing that I had two numbers. I don't know what they were. I did their prime factorization and I got this. How do I find LCM and GCF after finding their prime factorization? In the LCM, I look first at the commons. I see that 2 is a common, 3 is a common, 5 is a common, 7 is not a common, and 11 is not a common. This means it does not repeat in both. I take all of them initially without repeating. Without repeating, this means you don't take 2 power 3 and 2 power 5, you just take 2. Now, the highest power of each number will be taken. This means this will be 2 power 5, 3 power 1 and 3 power 2, I take 3 power 2, 5 power 1 and 5 power 4, I take 5 power 4. Regarding the non-commons, you take them as they are. That's the LCM here. If you can calculate it, you do. If not, you just leave it like this because that number looks too big to calculate. Even by calculator, it's too huge. Regarding the GCF, going back to the commons, the underlined red numbers, I will take them all because they are commons. Anything that is not common, I will not take it in the GCF. And any common, I take its lowest power only. That's the GCF, the greatest common factor of these two numbers. This is how I find LCM and GCF. In the next video, we will talk about real life applications about LCM and GCF, which will be more practice about finding them. And I will focus on the prime factorization more than the classical method. Also, it will be a good chance for you to understand how LCM and GCF appear in real life. Stop.